Why does New York freeze under a thick blanket of snow each winter, its streets and parks transformed into a frozen wonderland, while Madrid, a city at nearly the same latitude across the Atlantic, enjoys winters that are noticeably milder, with people strolling comfortably through its lively streets? The answer to this striking difference isn't found on land, but hidden deep within the vast, restless ocean that separates them. Both cities are equally distant from the equator, sharing similar positions on the globe, yet their winter experiences couldn't be more different. The secret lies in a powerful ocean current, a river within the sea, called the Gulf Stream, which flows like a hidden force beneath the waves. This current acts like a massive conveyor belt, carrying warm water from the sun-drenched tropics all the way across the Atlantic to the shores of Western Europe. Thanks to the Gulf Stream, Europe's climate is far gentler than its latitude suggests, allowing cities like Paris and London to enjoy winters that are much less severe than those in North America. Without this warm ocean current, cities such as London or Paris would endure winters as harsh and unforgiving as those in Canada, with snow and ice dominating the landscape. The Gulf Stream is one of the planet's most powerful and influential currents, shaping weather patterns and temperatures for millions of people on both sides of the Atlantic. It's a lifeline for Europe, making much of the continent not only habitable but also comfortable, even during the coldest months of the year. The story of why American and European winters differ so dramatically begins in the warm, sunlit waters near the equator, where the Gulf Stream is born. This incredible journey, driven by the Earth's rotation, the movement of wind, and the unique physics of water, explains why Boston residents bundle up in heavy coats and scarves, while in Porto, Portugal, people might only need a light jacket to stay comfortable, even in the heart of winter. The Gulf Stream is the silent, unseen force behind this remarkable tale of two winters, quietly shaping the climate of entire continents. Let's dive deeper into how this mighty ocean current shapes not just weather, but the very way people live and experience the seasons. The answer to this climate puzzle is hidden in the sea, waiting to be discovered and understood. Picture a river, not on land, but surging through the vast expanse of the Atlantic Ocean, a powerful, invisible force shaping the world as we know it. This is the Gulf Stream, one of the most important and influential ocean currents on our planet. It's a massive, fast-moving current of warm salt water, carrying more water than all the world's rivers combined, an astonishing volume that moves with relentless energy, day and night. Heated by the tropical sun in the Gulf of Mexico, the Gulf Stream becomes a ribbon of warmth slicing through the cold Atlantic, creating a striking contrast between warm and cool waters that can be seen from space. The Gulf Stream is a crucial part of the Atlantic Meridional Overturning Circulation, or AMOC, a global conveyor belt for heat that helps regulate temperatures across the entire planet. As it flows north, the Gulf Stream moves with surprising speed, sometimes racing at several miles per hour. It can stretch over 60 miles wide and plunge nearly a mile deep, making it one of the largest and most powerful currents on Earth. Sailors have long noticed the sharp boundary where the warm, deep blue Gulf Stream meets the colder, greener waters of the North Atlantic, a visible line that marks the meeting of two worlds. This mighty current delivers tropical heat all the way to Europe, making its climate much milder than its northern latitude would suggest. Without the Gulf Stream, winters in Europe would be far harsher. Benjamin Franklin was among the first to map the Gulf Stream, using his observations to help ships cross the Atlantic more efficiently and safely, revolutionizing transatlantic travel. His pioneering work revealed just how influential this ocean river is, not just for navigation and travel, but for shaping the climate and weather patterns of entire continents. The Gulf Stream's power is felt far beyond the ocean, shaping weather, influencing storms, and even affecting the daily lives of people living thousands of miles away from its path. It's a force of nature that connects continents, cultures, and climates, weaving together the destinies of nations on both sides of the Atlantic. Understanding the Gulf Stream is key to understanding our climate, our weather, and the future of our planet in a changing world. Let's dive deeper and see how this mighty current moves, and why it matters so much to life on Earth. The Gulf Stream's journey begins in the sun-drenched waters of the Gulf of Mexico, a region known for its warm, inviting seas. Here, warm water flows out between Florida and Cuba, creating a powerful current that hugs the U.S. East Coast as it makes its way northward, bringing warmth and energy. This current is crucial for keeping coastal areas like North Carolina milder during winter months compared to the colder inland regions, providing a buffer against harsh weather. As it moves past North America, the Gulf Stream transforms into the North Atlantic Current, carrying its warmth across the ocean to Europe, influencing climates far from its origin. The driving forces behind this incredible journey include Earth's rotation, the persistent trade winds, and the thermohaline circulation, an intricate system driven by variations in water temperature and salinity. As the current approaches the icy waters near Greenland and Iceland, it cools significantly, releasing heat to the atmosphere and becoming denser, a critical part of its cycle. This cold, salty water then sinks, initiating a deep return journey southward, a vital component of the ocean's circulatory system. This sinking and rising motion is the great engine that powers the global ocean conveyor belt, a system that circulates water and heat around the world. The Gulf Stream cycle is a continuous loop, tirelessly moving heat and water across the planet, influencing weather and climate patterns globally. This process plays a crucial role in moderating temperatures, preventing extreme cold in Europe, and ensuring a more temperate climate. It's a slow, steady transfer of energy with a profound global impact, affecting weather patterns and climate stability across continents. The Gulf Stream's movement is truly the heartbeat of our climate system, a dynamic force that sustains life and balances our planet's climate. As the North Atlantic Current nears Europe, it releases stored tropical heat into the atmosphere. Westerly winds pick up this warmth and moisture, carrying it across Western Europe like a giant central heating system. Countries with long Atlantic coastlines, like Ireland, the UK, and Norway, feel this effect most. Ports in Norway stay ice-free, and Ireland's lush green landscape thrives year-round. Even cities far inland, like Paris and Berlin, enjoy milder winters thanks to this oceanic warmth. If the Gulf Stream weakened, Europe's winters could become as harsh as Canada's, with shorter growing seasons and disrupted ecosystems. Europe's mild climate is an anomaly, made possible by this distant river in the sea. The continent's comfort depends on the Gulf Stream's steady flow. Let's compare New York City and Madrid, two cities at nearly the same latitude but with very different winters. In January, New York averages around 0 degrees, 32 degrees, with snow, icy winds, and deep freezes. Residents bundle up for harsh continental winters. Madrid, meanwhile, averages about 6 degrees, 43 degrees in January. Cool, sometimes chilly, but rarely bitterly cold. Snow is rare, and sunny days are common. The difference? Madrid benefits from westerly winds warmed by the North Atlantic Current. New York, despite its coastal location, gets cold air from the continent, not warmth from the sea. The Gulf Stream's warmth is delivered to Europe, not the US East Coast. Ocean currents and wind direction create this dramatic climate divide. It's a real-world example of the ocean's power over weather. The Gulf Stream hugs the US coast but doesn't warm it like it does Europe. Prevailing winds in North America blow from west to east, bringing cold, dry air from the continent. With no major east-west mountains to block Arctic air, frigid masses sweep down from Canada, causing dramatic cold snaps and blizzards. When this cold air meets the warm Gulf Stream offshore, it fuels powerful storms called nor'easters. The nearby ocean can intensify winter weather, not soften it. The cold Labrador Current also chills the northeast, meeting the Gulf Stream and keeping waters icy. America's winters are shaped by a mix of cold winds and clashing currents. Oceans and winds work together to create our climate. Water's high heat capacity lets oceans absorb and store vast amounts of solar energy, buffering coastal climates. Winds, driven by pressure differences from uneven heating, transport heat and moisture from ocean to land. The direction of prevailing winds is crucial. Westerlies bring warmth to Europe, while other regions get different effects. Monsoon winds in South Asia, for example, reverse seasonally, bringing rain or dry spells. This partnership between ocean and atmosphere is a delicate feedback loop. Ocean currents influence wind patterns, and winds drive the currents. Small changes in either can shift weather worldwide. Understanding this relationship is vital, as global warming alters both ocean temperatures and wind patterns. The balance between wind and water has kept Earth's climate stable for millennia, but it's sensitive. Tiny shifts can have big consequences. Our future climate depends on this intricate dance. The story of wind and water is the story of our weather. The Gulf Stream is part of a global conveyor belt, circulating water and heat between all major oceans. Warm surface currents move heat poleward, cold, deep currents return it to the tropics. This circulation evens out the planet's temperatures, connecting distant climates. Events like El Niño in the Pacific can shift weather in the Atlantic, showing how interconnected our climate is. Climate change threatens this balance. Melting ice adds fresh water to the North Atlantic, making it less dense and potentially slowing the Gulf Stream. A slowdown could bring colder winters to Europe and shift weather patterns worldwide. Sea levels on the U.S. East Coast could rise faster as the Gulf Stream changes. The health of this system is crucial for billions of people. A change in one part of the ocean can trigger global effects. Our climate's stability depends on this delicate worldwide network. The answer to our climate puzzle is found in the wind and waves. America's winters are harsh because cold continental winds sweep south, while Europe enjoys warmth delivered by the Gulf Stream and westerly winds. This oceanic influence gives Europe its famously mild winters, despite its northern latitude. The story of two continents shows how geography, ocean currents, and wind direction shape our world. Climate is a recipe. Latitude, altitude, ocean proximity, and wind direction all matter. Next time you see a blizzard in Boston and rain in Lisbon, remember the invisible river in the Atlantic. The forces of nature create the beautiful diversity of our living world. Our climate is a masterpiece, painted by the sea and the sky.